Hello, I'm Pushkar, Master Teacher in Chemistry at Vedantu, and I'm discussing KVPY 2019 Essay Part 2 Chemistry paper. Here's a question from atomic structure. We have to choose the correct statement. E of 2H, 2S, E of energy of 2S orbital in H, lithium, sodium, and potassium. We have to compare. The maximum number of electrons in this shell with principal quantum number n is equal to 2n square. Extra stability of half-filled subshells is due to the smaller exchange energy. Only two electrons, irrespective of their spin, may exist in the same orbital. And we have to see what are the correct statements. So let us talk about the first one. Energy of 2s, energy of 2 lithium. If you compare them, the best thing to do is to Bohr's model. Go for the Bohr's model, and if we talk about the 2s energy level or any energy level, it depends on the z. So if Z effective is more, then energy decreases. So clearly Z effective will be more, in which case most in the case of potassium and least in the case of hydrogen. So of course it is the correct option. First option is correct because Z effective affects the energy. How do you know this? Because we know this that En for the Bohr's model, we got this En is equals to minus z square upon n square into constant. So that gives us the idea, greater the value of z, more negative and the bigger value of energy will be there, and more negative it is, lesser is the energy. So obviously the option 1 is correct option. We have to look for it. So option 1 you can see here. Option 1 you can see here. So two candidates are there, A and D. Now let's see the second option. The maximum number of electrons in a shell with a principal quantum number n is 2n square. Can we prove it? Of course we can prove it. And to prove it, we know that for any shell of number n, how many subshells are there? 0, 1, 2, up to n minus 1 subshells are there. And for 0, 1, 2, etc., the number of orbitals in them will be what? Number of orbitals will be corresponding to this will be 2l plus 1. So basically we have to do what? 2l plus 1, and we have to summate it from L is equals to, let's call it Li, and Li is equals to from 0 to n minus 1. That summation will give us what? If you do this summation, it will become a series, and if you just sum it up, you will get n square. Okay, is it understandable? So I want to say that you are going to get terms like this. For 0, you are going to get 1 plus 3 plus 5 plus, and up to, for n minus 1, L is equals to n minus 1, you have n minus 1 twice of this plus 1. So that is 1 plus 3 plus 5 plus, and that is 2n plus minus 2 plus 1, that is 2n minus 1. How many terms will be there to get this? This is corresponding to L is equals to 0, this is corresponding to 1, this is 2, and this is corresponding to n minus 1. So which term this one is? This is n minus, this is nth term. So in nth term you are going to get this. So that is sum of the nth term. You can do it and you can find out the sum of the nth term. If you do summing all these values, what you are going to get? 2n minus 1, that is the last term, plus first term is 1, last term plus first term into n by 2. So that is equal to what? N by 2 into 2n, and that's of course n square. So you can prove that n square will be the sum. Okay, but these n square will be only the number of orbitals, and each orbital contain what? Each orbital contain 2 electrons. So this means that total number of electrons will be 2n square. Got it? So We understand this, that maximum number of electrons, this statement is correct, this statement is correct. Now no need to go any further because only these two options seems to be correct. Option A, 1 and 2 and 1 and 4. Of course 2 is not there. So by choosing options, A should be the correct option. But let's also read out other options as well. Extra stability of half-filled subshells is due to the smaller exchange energy. No, it is larger exchange energy because in a half-filled orbital, if there suppose a d orbital is there and they are symmetrically placed, so if the spins are identical, you can exchange this with this, or you can exchange this with this, you can exchange this with this, and you can exchange this with this. So these exchanges will lead to what? Similar configuration. So how many exchanges are there? The one could be exchanged by this, as four options are there. This can be exchanged by this and this and this. So 4 plus 3. This can be exchanged by this and this. 4 plus 3 plus 2, 1. This can be exchanged by this plus 1. So 4, 3, 7, 2 plus 1, that's equals to 10. So you can say 5C2 or 10 exchanges are possible in a half-filled shell. So these are lot number of exchanges. Okay, so extra stability of half-filled orbital is not due to smaller, it's due to larger exchange energy. So that option is of course incorrect. Only two electrons irrespective of their spin, that's wrong. Respective of their spins, because two electrons with opposite spin can exist in the same orbital. It's not possible that two electrons with same spin can exist in the same orbital. So obviously this option 4 is also incorrect. That is against the Pauli exclusion principle. So only options you are left with is 1 and 2. So I hope that you understand this solution. Stay tuned for detailed discussions of such questions. Thanks for watching.